Welcome to everyone to the second European webinar for CLT Toolbox. So today we're going to be covering lateral stability and connections design of a post and beam office building. I'll just be opening for you at the beginning. Marko will be doing the majority of this, but I'll be helping to host the Q&A together. So what are we covering today? That's what I'll be covering in the next slide. Then a very brief thing about us. Who are we, CLT Toolbox? We assume that most of you know who we are, but we always like to do a brief introduction. We'll then cover some housekeeping, a bit of a summary of some of the support options in the app that we recently implemented. We'll be covering our latest release, and then we'll get into the design examples and a Q&A in closing. So, of course, Nick, of course, to everybody, please, we encourage you to comment in the chat. We encourage you to drop questions into the Q&A. We love engagement. We love jokes. We love serious questions. Everything. This is designed to be as interactive as it can, given that we're on this side and you're listening. So what are we covering today? This legend right here, Marko, he will be covering wind analysis and diaphragm design, considering strength and serviceability, floor-to-floor detail design options and optimization, K-brace member and connection design using the wood-steel-wood Dowel calculator, which we recently released. And for connection design, we'll be covering the new Eurocode inputs and comparing design outputs. So, hey, Philip, thanks for the shout out. Anyone who says hello in the chat, hey, Henry, I'll be saying hello back to you. So we encourage you. We do love Marko. So briefly about us, CLT Toolbox. We are a team of 45 software and structural engineers globally. We now release new calculators and features every 2 to 3 weeks. And we have calculators, despite the name of CLT Toolbox. We're not just CLT. We have CLT, we have GLT, we have LVL, light frame, and connections. We only started a couple of years ago, actually, in mid-2023, and we're now live in Australia, New Zealand, Europe, UK, we're launching soon in North America, and we've had over 3,300 user signups in that time. And we're partnered with nearly 20 product suppliers in the mass timber industry. So we love what we do. We're passionate about the infrastructure that we're building, and we're a big group of people who are really thrilled to be working with you. So just briefly on housekeeping for this webinar today. So you can find all of our previous webinar recordings on the community forum, which is where you are. So as you can just see on the left, you just click webinar recordings and you can see them from the past. For the Q&A today, you'll see in the chat, there's a little question mark that I've now enabled Q&A. So at any point, you can ask questions. If they feel really relevant to the moment, we may spotlight them, but for the most part, we'll probably answer them at the end, Marko and I. And we just want to highlight a new feature that we've got here, support options in the app. So number one, you'll notice over on the left in the app that you can actually access the CLT Toolbox community directly. So you will need 2 different logins, one for CLT Toolbox and one for CLT Toolbox community. We are improving that, but for now, that's what you need to do. But also, you'll notice this little question mark in the bottom that says contact us on the app throughout the app. And if you click that at any time, then you can send screenshots to do with any questions that you have. Hey, Teddy, thanks for that. So this latest release was one that we're very proud of. We released this about a week and a half ago. So it was the new steel beam CLT calculator. As you can see, the GIF operating on the side. We updated 6 of the Dowel calculators, and one of them is being used in this webinar today. As you saw, the community forum now exists. Screw filtering now exists, so that when you're using our screw calculators, you aren't accidentally designing with screws that aren't suitable for the scenario that you're designing. And of course, we've updated the partners projects on the login page. And so this calculator here will be free for the next month so that you can use it and try it too. So before I hand over to Marko, I just, of course, want to say thank you to all of our partners. This is a growing list, and this list will continue to grow in the near future. But we aren't here if it wasn't for the buy-in of our partners. So without further ado, it's time for the presentation. Marko, over to you, man. Enjoy, everybody, and I'll be back for questions at the end.
Thanks, Ringo. So let me just share my screen. Perfect. So hi, everyone. Once again, thanks for coming and welcome to the second episode of CLT Toolbox webinar series. I'm Marko, product manager here at CLT Toolbox and RBO host again. Let's get started. So after the first episode, where we did a preliminary analysis of post and beam office buildings, I'll take you through the lateral stability and connection design in this second episode. At the beginning, let's take a look what we had designed in the previous webinar. So in the preliminary analysis, we designed typical CLT floors, GLT beams, internal and external GLT columns. We got 5 layers CLT floor from KLH. We got 360 by 720 GL24C typical beams, 400 by 400 GL24H for internal, and 360 by 360 GL24H for external columns. And the important inputs for the horizontal stability are also wind loads. We have a building located in Amsterdam, and we'll be using Dutch National Annex. Also important to know that we have a basic wind speed of 27 meters per second. For load analysis, as shown in previous episode, we already have Eurocode calculations for wind analysis. We got the maximum applied wind loads for each surface for both X and Y directions, and we'll use these values for calculation of the diaphragm, bracing calculations, and connections in the end. Starting with horizontal stability, we have 4 vertical key bracings in both X and Y directions symmetrically placed around the building for the lateral stability of the system. Normally, we would use some of the FM software for precise analysis and of horizontal stability, but today we'll show you how you can use our platform in addition to some other software, FAM analysis, for example, or for a quick verification. Based on the latest analytical methods, our calculation can help quickly determine precise horizontal stability elements with some approximation. And for the CLT diaphragm, we will observe 4 simply supported diaphragms, and for the simplicity of the design, we'll assume they're all flexible. We have panel width of 2.67 meters, and we'll use half-lap connections. So at the beginning, just a few notes on what is the background of this calculator and what design guides and research papers we used. As there are no code-defined methods for designing CLT diaphragms, we use a combination of different guides and research papers. For the main analytical method, we used Proholt's design guidebook, second version from 2018, and the substitute D-beam analogy. For calculating deflection, we used in-plane deflection of cross-laminated timber diaphragms by Buffech, published by World Timber Conference in Oslo back 2023. And for calculating the stiffness of the diaphragm, we used state-of-the-art report timber floor diaphragms by Ilko Lucas. Also, concerning the key principles based on Proholt's method, we modeled the diaphragm as the substitute D-beam in the horizontal plane between bracing walls. And for dimensioning of the fasteners in the joints, it's assumed that the shear flow along the joint is constant and the axial forces are linearly distributed. Also, a couple of important notes for the deflection verification. We use mid-span deformation calculation from the first research paper with the slip modules calculated directly from Eurocode 5. And the total deformation is being calculated as a sum of panel bending deformation, panel shear deformation, and connection contribution. Also, we used from the second research paper from State of the Art, we used how the stiffness is being calculated with the diaphragm and what is the connection contribution. So here is just the preview of the analytical methods and formulas we use in this calculator. So we'll start with the design of CLT diaphragm in X direction. Here we have additional input needed for the design. So we have both factorized loads for ultimate and serviceability limit state loads, because we have both strength and serviceability checks. And also we'll use Eurotex screws for this connection, since we were considered slip modules within the calculation of the diaphragm. So let's jump to the app and start with the design. So the first, in our recent update, as Ringo mentioned in the beginning, we launched a community forum inbuilt into the app. So this is on the left. So if you want, if you have any questions related to the calculators in the app or in general with mass timber, feel free to join the conversation. Regarding our calculation, we can start with CLT diaphragms. So we'll create a new project on the company level. I'll type in, so webinar 2, and we can calculate CLT diaphragm, something like this, and we'll create this calculation. So at the beginning, we can set up what we have, either a manual input or a custom supplier, or some of the available suppliers that are we have already partnered with. So as we designed in the previous session, we'll start with we input the KLH 5 layers, 180 millimeters. Also important to know that this calculator is only available to Pro and Enterprise users. So on the right image, we have dynamic image of the preview of the geometry, connections, panel connections, and total of factorized force for ultimate and serviceability limit state. And below we have stored input, so similar to other calculators we have. So at the beginning, we can set up geometry first. So we can type in 24 by 12 meters. So we're going to take only one diaphragm, as we explained at the beginning. Or for the panel-to-panel connections, we can select a half-lap joint. Also, we'll configure the panel orientation to Y direction and also orientation to vertical. So we'll match the orientation from the diaphragm and the forces that are applied to this specific scenario. Also, what is important, we'll type in the panel width, so 2.67 meters as we have listed, and also we can start set up spacing as 150 millimeters. Also, what is interesting about the panel width and how you can start with selecting the proper dimension. You can always use more information from each supplier, and you have some technical about, besides some information about supplier, you have technical information where you can find maximum panel width and production, also for the production and transportation limits. So you can use this as a starting point for picking the right width of your panel. For the connection data, we'll use supplier specific, but also there is ability that you can use user-defined values or strictly Eurocode, or pick up the right supplier. So based on the appropriate producer, family, and exact type and diameter of screw, it will be included into the app. So for example, we can start with panel twist stick 6 times 160. And going further, we have option for selecting design. So this is set to Eurocode, ProHoltz, and ambient case. We'll leave all the inputs as they are. For the input forces, we have lateral deformation in Y direction that is set up properly. And also we'll type in the proper values that we have inputs with. So I'll type in for ULS 11.39, and for the serviceability limit state, we'll type in 7.59. For the in-plane share values input, so these inputs are left as a user input because they're not described for each supplier. So they are based on some recommendation from design guidebooks and other research papers, but you can find some specific with each supplier. So for instance, for the KLH, we can type in 5.2 for share net strength. So also in terms of the elimination data, this is also part of the inputs that are specific to supplier, and you can find more information in their technical data. So for the transfer lamellas, in this case, we'll type in 80 millimeters, and for the longitudinal, we'll type in 120. Going further, we have the last part of the inputs regarding the design data for Eurocode 5. So we have cases, gamma. We have option for deflection ratio, also a shear correction factor that is depending on the geometry and aspect ratio. Also, the key mode will change this to 0.9 because we have wind governing in our load combination, and we'll leave the service class to 1. For concerning the output summary, we have a preview of in-plane deflection, bending, shear, and in-plane tensile stress. We can see that the thickness of the panel is not governing, but we're going to go through these results in detail and see all the specifics and how we can use some of these results for calculating the connections. So going first into panel properties, we have information about the panels and the stiffness calculation for the in-plane deflection. So as mentioned at the beginning, we have here CLT diaphragm based on the substitute deep beam analogy. So it's based on the Proholtz method that we described at the beginning. Also, we have here information about the stiffness of the connection and how this is being calculated into the total stiffness. Also, based on the research papers we explained, we have information about the total and formulas listed for the total deflection. In this tabulated format, you can see step-by-step calculation, and in the end, we have information about the midspan, deformation of the diaphragm, and the total stiffness of the diaphragm. Also, below, we have information about the contribution of the connection to the overall stiffness and the advanced things that you can use for serviceability verification, and also compare with other tools. For going further, we have information in the actions. So we have here shear and bending moments actions in this tab, and in this strain tab, first we have information on the verification of the CLT diaphragm starting from in-plane bending design. And in this part, we have also determination of the joint forces from plane effect, and we can stop here for a minute just to see how we can use some of these values for our connection design. So we have here locations of each joint that we have in our diaphragm. So we have 9 axes, what is presenting 9 connections or axes of connections. We have location of each joint, and for each joint we have information about the shear forces, or even short force field fastener moment, but also axial forces. So we can use these values for determining and optimizing the connections in our panel-to-panel connection design. So we'll use 8x86 and 6x76 for the panel-to-panel connection. Forces are highest at the end, but this can be used for panel-to-beam connection. While we'll design panel-to-panel connections, we're going to use this one. Also, going further, we have information for further optimization on the panel design, tension and compression strain information, in-plane shear design, including all three mechanism types, also from Proholtz design guidebook. So going further, we'll take some of the information from the panel-to-panel connection from this diaphragm calculator as inputs for the next calculation. We can go quickly on the top. We'll click Save, and we'll go back to the next slide. So in this case, we'll see how we can start with panel-to-panel connection design. So we have different types of panel connections. So the exact type of panel connection depends on the producer, contractor price, and etc. But what we learned from the conversation with all engineers is that it's always good to have options. So no matter what is used for the beginning of the project, you know that you can easily change a type of the connection. So we have here, we can start with half-lap connection, and we have all the necessary inputs. We have the KLH panel, so we have 180 millimeters from KLH, as I mentioned. We have forces in the direction of the connection and perpendicular to the connection, and we'll start with half-lap width of 100 millimeters, and we're going to use Eurotex screws with suppliers ETA. So let's jump back to the app. I'll just zoom this a bit. So we'll go back on the project level, and I'll add a half-lap calculator here. So if you scroll down, you can see here floor to floor, and we'll select half-lap. We can start editing. And here we can start with the design. So first we have option for selecting the code. So we have Euro codes pre-selected. For supplier, we're going to select again KLH 185 layers. For the lap width, we can start with 100, as we mentioned. And also we have option for selecting floor type. So it can be either discrete or continuous. So if you want to design 1 meter strip, as we're going to go, we can select only continuous one. While if you want to check also what is the number of fasteners you needed for your connection, you can type in discrete and input the total length of the connection. We have option for also dynamic imagery. So we have top view, section A, section B, and we'll soon select the CLT, the connection supplier, so the appropriate screw with it. So we'll select Eurotech, as we mentioned. For the screw family, we'll select partially threaded screw washer type, and we'll go with the same screw as we used on the diaphragm design. So we can type in a panel twisted 6 by 160, and this will be automatically updated on dynamic imagery as well. And for the analytical methods, we have option for selecting either Eurocode or supplier's ETA calculation. So it's for all these methods, we have option always with ETA, and we always recommend that you use that in calculation, because more precise information from each supplier included, including rope effect calculation, intermediate edge distances, and specifics with the products and tip types. So that's also something that you can find with more information. If you want to check out what are the differences between some specific calculations, also worth mentioning that we have also, beside the current, we have implemented the new Eurocode. So I'm about to show you that at the end of the calculation as well. But for each type of calculation, there are some differences in shear, axial capacity, also for the incline and spacing of the screws. So that can be also important and can affect your design with some nuances, especially if you're short with the geometry and have specific inputs. For the screw geometry, we have a flush with member face, but also there's some options that you can put it with custom embedment length. We'll keep it vertical, but note you can also use incline and crossed. For spacing along, we can type in 150 as we have started, but this is represents an iterative process between the diaphragm and connection design. So this is something that we can only start with. For loads, we'll type in 8 by 86 as we have in the design, and 6 by 76 as a force that is applied perpendicular to the connection. For the design data, we have 1.3 for gamma. Load duration, we're going to pick up long term. As for wind loads, service class will keep 1, and pre-drilling will set no. So we started with inputs. We can see that geometry check is okay, but we know that the shear capacity is not proper. So we have option either to increase the diameter of screw, either to increase the spacing. So in this case, we can type it with lower spacing, 120. This is still not enough, so let's keep to 100 and see if this can help. So we can see that 100 millimeter distance between screws is something that we can use. Also, just to show you a preview between the results. So if we change back to Eurocode, we'll see that there's some difference in the results. So it's not too much, but that sometimes this can help to have a connection that can satisfy the requirements or not. Also, just a preview for the new Eurocode. So if you go back to the design code, you can switch between the current and the new Eurocode provision. If you go with the new one, you'll see that you have more conservative results in the new Eurocode verification, and that these for example, 100 millimeters would not be enough according to draft version of Eurocode 5. And in this example, we can stick with the ETA and the current Eurocode. And just a preview of results, we have information about the screw geometry. We have also lateral capacity, so rope effect calculations. Then we have characteristic axial capacity of the screw, then all the timber failure modes are listed here. So if you're interested, you can check all the numbers in details and trace the calculation where is something that can be interesting to you. But also in the here, if you scroll down, you can see the summary of all failure modes, what is the lowest capacity, and also what is the effective numbers of screw in the end. What is the shear capacity of the connection with all the references for each step as well. So we can go back, we can save this calculator, and we can go to the next calculation. So we designed the half lap connection. Now we're going to show you also how you can use the similar analogy for designing the spline joint. So as an alternative, we're going to use, of course, the same panel, the same forces, but we'll use the spline. At the beginning, we can try with 200 by 20 millimeters, and we're going to use this time SPAC screws with supplier's ETA. So again, let's go back with a webinar project. Here, we're going to add a new calculator, and let's select floor-to-floor spline connection. And let's start editing this calculator. So here, again, we're going to type in some of the same inputs. So let's go with Kyle H. Let's select 185 layers. So for spline, we can go with 200 millimeters. We're going to, again, select continuous, so only 1 meter strip. The strip is designed. For timber member, we're going to set 20 millimeters spline material, change to plywood, and I'm going to leave the density on 400, but that's specific to material you're using. For screw supplier, let's select SPACs, and here we can select some of their product families. Also, if you're not familiar with all the products, or you want to check out what are the alternatives at some point, you can notice that you have more information here covering all the information about the screws, covering their geometry, screw family, thread type, head type, diameter, length, service classes, and specification. So you can quickly find out maybe what is something that you can use in your design. So here we can start with Wyrex partially threaded screws. I'm going to select appropriate screw for this design. So let's just scroll down. I'm going to select the washer head, and I'll try with 8 by 80. Also, let's use SPAC's ETA in this case, and I'll type in 150 as for the beginning. For the appropriate loads, let's type in what we have, so 8 by 86 and 6 by 76 in the perpendicular direction. And for the design Eurocode, so we have gamma, we're going to select long-term, service classes, and no for pre-trailing. So if we go on the dynamic imagery, we can see how this is positioned. So we have spacing, we have a position of the screws. We're going to go to the results and see that the shear capacity in this case is not appropriate. So we have geometry check fulfilled, but we need to either increase spacing or screws. I'm not going to increase the diameter of screw because I think the spacing on this is already at maximum. So let's try to have a less spacing. So if we put to 120, we can have the shear capacity fulfilled here. Also, the difference within the ETAs and the Eurocode here can be seen in the geometry check. So if you use the ETAs from supplier, you can see that the provisions for and recommendation for the distances between them is something that is more favorable within the ETAs. For the output summary, so as I mentioned, we have geometry check shear capacity. We can go in details and see all the information, and if you want to check what geometry is not appropriate, you have ability for that. And for lateral capacity, again, we have all details, results in this as we have for the previous calculator. So having said that, I can click save, and we can go back to the presentation and to the next calculator. So going further, we showed how we can use diaphragm calculator and how we can use some of the information for designing panel-to-panel connections. Now we will look the other direction of the diaphragm and see how we can design members and bracings that are supporting in that direction. So we'll just calculate the force transferring from the diaphragm to the vertical bracing based on the tributary area here. So we're not going to use the diaphragm calculator for the other direction. We'll have total wind speed acting in the y direction, and we'll determine the total force acting on that is transferring to the beam, and what is that is part of the vertical bracing system. And we'll use this force for designing the connection between the diaphragm and bracing, but we'll leave this for the next episode. In this case, we'll show you how determining force. You can determine force in bracing element, but since this is a complex calculation, we'll use additional software since we don't have this analysis as part of our software. And also, this is a good example to see how you can use our tools together with some other tooling and FAM calculations. After the analysis, we will design a bracing member and connection and see how connection can impact the member design. So based on the geometry and selected loads, we have governing loads for maximum tension and compression in this bracing element. We got maximum tension for 1.2 G plus 1.5 W load combination, and maximum compression for 1.2 G plus 0.75 Q plus 1.5 load combination. So we can see that wind is governing in both load combination, of course, and we have information for every element in this bracing system. So we're going to design only the ground floor elements. So we have loads in diagonal. So maximum tension force is 68.32 for tension, and for compression we have 175.13. Same principle applies to every element in the bracing, and also important input that we need is that K mode is 0.9 because wind governs in both load combination. Also, we have diagonal length of 5.66 meters. So let's go to the app again. So I'll go back on the project level, and we'll use this time member calculator. So here on the member, we have also timber member calculator. We can type in member, or better, diagonal D1. And we can check what would be the appropriate dimensions for this element. So for the beginning, we have option for selecting the design codes. We have Eurocode calculation. We'll select diagonal brace. For length, we have 5660 millimeters. We have for load duration, we're going to input the short term as we have wind. And for the section analysis, this is just information about dynamic imagery. So this is something that is not relevant for calculation. It's just information about where the forces is applied from the section you want to check. So in the member data, what is important, we're going to select the manual input. We're going to select GL24H, and we can start by 180 times 180, for instance. And for the design action effects, we're going to type in appropriate forces applied in this section. So we'll type in 0 for the moments and for the shear forces, and we'll use only this actual force designer so we can check tension and compression. Since we have much higher compression, we think this will be governing. So let's type in just 175.13 and type in the appropriate Eurocode part. So we have cases, service losses, and effective length factor set to 1. We're going to leave on this. So if we go with the results, we can see that the compression and stability check is at the optimum level. So maybe we can leave with this section and see how this will pass to the connection part. For the in this result tabs, we have information about the material properties. So we used GL24H. But here in the design checks, you can have all the results if you want to go more in detail and see information about the stability and compression in this case. If we want quickly, we can just verify what is happening with tension. So in this case, we can type in 68.32, but I don't think this will be governing. It won't. So let's just convert to compression, 175.13, and we can go above and click save. So as we design now the member and we know with the section, let's go to the connection part. This will also be interesting to see how this will affect the member sizes. We're going to use the same forces, and we're going to use our recently updated large Dowel bolt calculator. So again, let's get back to the app, go to the project level, and we'll select the appropriate calculator. So it's important to note that we recently updated these large Dowel bolts. So we have first 6 calculators, a Eurocode ready. So for this case, we're going to use wood, steel, wood parallel to grain because we have only that situation, but also if you have any if you have any need to check other calculators, they are also ready to use. So in this case, we'll use the same naming. So we can use diagonal D1 just with the connection, and we'll start calculating this part. So at the beginning, we have the option for seeing dynamic imagery. We'll start with the inputting the design load. So we'll start with 175.13. We're going to type minus because we have compression in this case. So this is also something that you can see in the imagery parallelly. So we have Eurocode calculation, European yield model, and I'll jump to connection configuration. So here we have option for configuring both steel and wood members. So we will leave material to S355. Thickness we can set to 10 millimeters. We have option for selecting both bolts and dowels. First, we can set the material for the timber. So we have GLT, manual input, GL24H. We're going to have thickness the same as we started on the member design, so 180 by 180. Also on the fastener properties, we can select the appropriate grade of the bolts in this case, and I'll try with 16. Also, you have option with washer diameter, and the last part for the design and the Eurocode parameters. So we'll type in K mode 0.9, and we have also modification factors for connection and material. So now we can set up the number of rows we're going to use. Let's try with just 2 bolts per row, so 4 bolts in total, and we can type in the spacing for this. So let's try with 80 millimeters spacing and 15 from the edge. If we go back, we can see on dynamic imagery how this is shown. So we see that this is centrical placed on the member. Also, what is important, firstly, we can see if the appropriate numbers of fasteners is being used. So we can see that for this force, we need more fasteners. We'll try to fit them out, but of course, I'll switch to steel dowels in this case, because for this type of connection, this is mostly used. So with internal steel plate and steel dowels. Also, I'll set the strength to be higher to match the steel plate. We can see this is even more on lower capacity, because for the dowel calculation, rope effect is not included. So in this case, we know that we need to either increase the number of rows or to increase the section sizes, because we know that we can fit 3 rows in this case. So what we're going to do is I'll increase the size of members. Just an example how connection calculation can determine also and be governing for the overall member sizes. So let's type in, if we want to get another row, I'll just type in 260. So in this case, we can try with 3 rows, and number of fasteners per row, I'll try to get 4. So in this case, we have much larger section, but also a lot more fasteners. And hopefully this is something that we can have with the intermediate distances that we used. Also know that here on the more information part, you can see what parameters you need to change to fulfill the requirements. And if you scroll down to dimension check in the results, you can see all the recommendation values and criteria. So what you need to fill to match your design with what is required. If we go back, I think this is something that is fulfilling. So we have resistance at 80%. So we can say that this configuration and design is proper, but just to note that this is something that requires a bit more time and attention to find the perfect balance between what you need for the connection point of view and also from the member. But in most cases, the connection will govern, especially if you consider that you have fire design when you need to include that you have reduced cross section. So that will affect the cross section a lot. So that being said, we can go quickly through the results part. So we have here dimension check as we've shown. We also have design parameters, so information about what is properties of the timber member side, and also in the strain part you have all the calculation stored here. So starting with the rope effect calculation, then effective numbers of screws, also the failure modes, and all the intermediate step of the calculation. Also, what is interesting, we can quickly observe what is happening if we change to the new Euro code calculation. So this is also something that we have part is in all the connection calculation. So just observation on this part, as the calculation are a bit advanced and haste compared to the current Eurocode. We have additional failure mode, and in this case, for the new Eurocode, steel is detected as a member. So that's a part also in case of the brittle failure modes is that there's some advancement on the calculation and also what is required to be checked. Going further, we can in this case keep to the current Eurocode. And click save on this calculator, so I can come back to the presentation. So we have designed in the end what we need for the cross section, what we need for the type of number of fasteners, and also the type of fasteners for the connection, and show how it can be affected in the overall bracing design. The similar analogy applies for the other members and other parts of the connection of the bracing system. What I will show you at the end. So we are nearly finished this webinar explanation and project that we shared with you. I'll just quickly show you about the new US-Canada floor calculator. So if I'll just come back to the app and switch to something that we are at the moment testing for before we're going to officially release. So we are nearly about to launch the beta program for the US and Canada. So here is the preview of the floor calculator for the US. So we have option for a similar architecture as we have for the Europe, Australia, but here there is option for selecting a different supplier. Also for manual configuration, you can go with PRG 320. Also the layups and grades are available through the layup section. Everything is set according to NDS from 2018. There is ability for selecting different type of loads. Also, code is set to appropriate standard. Also, design philosophy is possible to change between ASD and LFRD. Some of the specifics for the inputs are the similar. Also, for the analysis, there is ability for changing the analytical methods, spans, conditions, some specifics for the North American codes, deflection data, and also vibrations. And just a preview that this is something that we'll be about to show. Similar analogy with what we have developed with the Eurocode, so everything will be visible, and for all the information about the loads, analysis, deflection, vibration, and design codes will be included, just appropriate to both US and Canadian code. So that being said, I think we are nearly the end of the presentation, so we can leave some time for questions. So I'll stop here and looking forward for your questions, and of course the next episode that will occur next month. So thank you, and over to you, Ringo.
Well done, Marko. And thank you to everyone in the chat, mainly Nick, for commenting while we were going along too. So awesome presentation, man. We've got a few questions here, and we'll kind of start from the first one. So quick spotlight. So yeah, this is an interesting one. Is there a way to automatically connect values between different calculators? Do we have that functionality yet?
Yeah, that's a great question. We don't have a yet option for connecting a calculator. So at the moment, the values you calculate from one calculator, you need manually to input to another one. But that's definitely something we're working on. So especially that will be important for this type of example we've shown, and also in the preliminary analysis where we have designing floors, beams, and columns, the flow of how you can calculate one member, get the reactions for one and input to the other is something also that will pop up. So that is definitely something we'll increase and add into the future. But thanks for the question.
I would probably put that in some of the top 3 requests that we get from people in demos for sure. So we're working on that. So I will mark that as answered. All right, we'll spotlight the next one. So thanks, Marko. I was wondering if we can have fire from the underside for this connection details. Can you? And
at the moment, no. For we're now in the latest stages of adding fire to the member calculators. For the connection is something still what we're developing. At this stage, it will be only possible to manually configure what is happening on the member side and see how that impact the connections. But definitely something we'll work on and add into the future development, as fire is a big topic we are working on.
Do you want to consider maybe doing a brief sneak peek of the upcoming fire calculator, given the fact that we've been asked about the fire here? Do you have one of those?
Yeah, I think we should show that on the last webinar, but I can pull up as well.
Yeah, I reckon we've got enough time to share that. I don't think people can upvote my suggestion to do that, but it's always worth showing. So I think, when is the expected release date for this fire calculator, Marko?
Yeah, I think it will be by end of this month. Not to say I don't know if software team is on the call, but I think it will happen this month for sure.
Cool. So you're pulling it up now?
Yes, just a second.
In the meantime, if anyone else has more questions, and I know I encourage jokes, but we probably don't need more jokes from Nick. But if anyone has any questions, we are in the Q&A here, and we have 10 minutes to keep answering that. But it's good to see some upvotes on these questions too. So I probably put you on the spot there, Marko, to quickly whip up the fire calculator. But looking at the audience, I think there's enough new people that it's worth quickly sharing. Yeah.
So the functionality about the fire will be stored with the member or ambient design. So it will just with the addition to the member design and everything that is designed in the CLT floor ambient, it will be option for just add calculator fire. Within that, all the inputs will be taken from the ambient design, so grades, suppliers, loads, and national annex parameters will be added into it. In this part, we're only concerned about the fire. So what is the fire resisting time, charring rates, glue line integrity, what is the exposure side, and also some of the factors for your code. But the biggest flexibility is built around possibility for checking the whole build-up. So you can select as many layers, protection layers you want, and for each layer, you can configure what type of protection you want to use. For each type of protection, you also have ability for selecting either manual input for calculation protection or for the Eurocode calculation, so that will be affected together. And in the dynamic imagery, you always have a preview of what is the reduced cross-section based on the protected materials you've been using on. In the result part, you have option about the charring and what is the total calculation behind that. Also note this is based on the latest draft version of Eurocode, so latest standard for the fire design. Also on the stiffness calculation based on the reduced cross-section, also about the loads, analysis and design, but only based on the appropriate annexes and selected properties and inputs. So that's about
amazing.
Quickly.
No, well done, and nice to see more questions coming through. So I'll just here's one here. So is there any intention to develop 3D imagery for the connection design? I think there was a 3D on the Dowel, wasn't there?
Yeah, that's correct. We started the implementation on the 3D. Definitely something we will work on this year, as we have a lot of requests, and also it's very useful when you have ability to design something to have it exported with some basis of IFC or set files or any other files that you can use for modeling. So definitely what we'll work on, but at the moment it's limited only for the calculation.
Perfect. Yeah, true. So it's just an imagery thing, isn't it? So then next we have a question from Nicholas. So Marko, can you give it a bit of an explanation around the pros and cons of inclined screws against vertical screws?
And this is
I don't know.
Great question, Nick. No, this is an amazing question. We're gonna have a next webinar series explaining in detail about the detailed design and connection. So this will be a big topic of the next webinar series. So I'd like to also use this opportunity to invite you for the other webinars episode. So in that part, we're gonna talk about what is the pros and cons using the incline screws compared to vertical, and how that can impact the design and save a lot of resources and save the connection design entirely.
Yeah, good shout out then, Nick. So next question. In these calculations, there is any seismic performance inputs in earthquake-prone areas that's important. So do we intend on having a solution for that?
Yeah, so at the moment you can, because all the connection design we have at the moment are based concept that you input the factorized load. So no matter what type of load you have, you can input it directly, and based on the K mode and other factors, you can configure that is affecting only the seismic design. What we are working on and what we'll include also is the specific recommendation and inputs for the seismic. So the user can be guided, especially for the new Eurocode, what type of failure mode are restricted, and what or some inputs for the or restrict factor, ductility, and some specifics that you need to include for the seismic design. But nevertheless, you can still use our calculators. It's just up to the user to properly input all the inputs based on the seismicity and see what are the nuances in the results needed to fulfill all the requirements.
Great answer. And I would also say that is probably in the category of the type of thing that if you're looking for ways to use our app in a way that doesn't feel that obvious, then just reach out to us, and obviously we're available anytime to speak with anyone. So this one has a lot of upvotes, 4 upvotes. I wish I could see who had upvoted it. I'll let you answer this question.
This is also one of the great questions. So yeah, Global RFM is a very powerful RFM tool. So it's something that is can address a lot of global analysis part, but great that you point out how this can be used together with our tool. So the best answer for that is lies in the specifics of the member design and also the connection. So whether you prepare a global model in the global RFM, you also need to consider what is the rigidity and stiffness of the joints. So by having the proper number, you can use our calculators, and practically in each calculator you have option for selecting the exact type of fasteners, spacing, and not just to calculate the connection, but also to get what is the slip modules values that you can use back into the RFM model and get by a few iterations more precise behavior and all the information and forces and deflection of the total model. So that's the first step. The second step is also, as I said, calculating the connections, and also within that you can export some of the forces and work with the verification in our app based on the members. So also what we will work this year is have the clear interoperability between, for instance, global RFM and our tool, in terms of if you export bulk Excel file or CSV, that you can import into our app and get verification for the members simultaneously. So that is also something we have on our roadmap. But thanks for the question. It's a great point out. I think, Ringo, you're mute.
Thank you. Yeah, and that's our intention, is to work collaboratively in the ecosystem as well. I'll just spotlight Henry's here because he was kind enough to do it, not on anonymous. Thanks, Henry. So do you have an answer for this one, Marko?
Yeah, block share. Yeah, it's taken into account in all the large Dowel vault calculators. So in the calculator details, you can see all the checks that are included. Beside the failure modes, block share is also included, and all other important checks, both for current Eurocode and the new Eurocode.
Amazing. Yeah, so that's a big yes, is that one. And I think the last, how do I do that? Last question here, and then I'll wrap things up.
Will there be a connection Dowel calculator for? Yeah, so also a great question. So at the moment, our large Dowel calculators are only limited for single force inputs. We are now working on the 2.0 version where all of these models will be combined into one. Besides the simple connection, also moment and shear forces will be available for selecting the input. So more powerful tool is coming soon. So
amazing.
That will be very useful for all types of connections.
Well, firstly, Marko, well done, man. That was awesome, and I can see people jumping out. So I will just quickly share with everyone. So the next webinar, so we will be doing these every month. It will be on April 2nd. You also have Corey and I will be there. So on April the 2nd, we'll be talking about the CLT floor to beam, CLT floor to steel, custom beam to column, GLT beam notch, and a sneak peek on the floor penetration. So every month we will try to improve the detail of the scenarios to be suitable for people in ways that they could use it in their jobs. We do 40, 50 demos a month, so we learn a lot about what people need. And of course, for anyone who wants a call to action out the back of this, we're offering 30-day free enterprise license trials to attendees from today. So just reach out to me if you're interested. So without further ado, I just want to say thank you to everyone. Henry, you replied to your question. Also CLT according to guidance. We will email you on this, Henry, as we're just finishing this up now. Just want to say thank you so much to everybody who came along today for the webinar, and we look forward to seeing you next month, and have a lovely day.
Thank you, everyone.
Bye.
Bye.